I gave you first term, okay, a equals to 8 and r equals to 3. We have to find the fifth term of this number pattern. Before starting this, you have to think about the common common term. How to find the common term? Tn equals to a r power of n minus 1. A r to the power of n minus 1. In this formula, we can substitute those values to find our answer easily. Okay, T5 means for n, you should substitute 5. So T5 equals to, what is our A here? 8 into R. Common ratio, that is 3. N. For n, we are substituting 5 minus 1. 8 into 3 to the power of 4. 3 to the power of 4. You have to find what is 3 to the power of 4. So 3 into 3 into 3 into 3. When you multiply this, 3 3s are 9, 9 3s are 27, 27 3s are 81. So 8 times 81, 8 times 81, it should be 648. 648. This is the answer for this particular geometric progression question. Okay, a equals to 8, r equals to 2. In this case, you have to write your 8th term. That means 8th term, T8 equals to a into r to the power 1 less than this number. So power of 7. So a is 8 into 2 to the power of 7. 8 can be written as 2 power of 3 into 2 power of 7. Yeah. While multiplication, if the base are same, you can add the powers directly. So 7 plus 3 is directly 10. 2 to the power of 10 is the answer for this particular question. Okay, in this question, you can see r equals to 3, fourth term equals to 54. So fourth term means T4, a into r to the power 1 less than this number. So it's 3. A, we don't know what is our A. T4 equals to 54. R to the power of 3. That means 3 to the power of 3. 54. A into 3 to the power of 3 is 27. You have to simplify this. Okay. Just divide this 54 by 27. So A equals to 2. A equals to 2 in this question. Now let's discuss one more question. Yeah. In here I'll give you A equals to 5 and seventh term of this geometric progression is 320. You should find all possible values for common ratio. What is this question? Just think about it and try this. Okay, when you look at this question, it's not much difficult. Okay, let's see. A equals to 5, seventh term 320. Okay, seventh term means all possible values for a common ratio. Seventh term, so T7 equals to A into R to the power of 6. T7 320, A equals to 5 into R to the power of 6. When you divide this 320 by 5, that is equals to 64. 64 R to the power of 6. Okay. First of all, find the square root of both of these. Okay, you have to find the square root for both of them. When you find the square root, it's 8. Square root for this, it's R to the power of 3. Okay, you can directly write, okay, 8, okay, R to the power of 3, 2 to the power of 3. So we can directly write R as 2 here. This is one of the method. Otherwise, if you have to find, okay, in the question they will ask us to find all the possible values. Now in this case we can't use this method. Okay, this method we cannot use. Okay, here which method we can use? Here we found r to the power of 6 as 64. 64. Yeah. It should be negative or positive, or plus or minus 2 to the power of 6, that will give you 64. Okay, you can check. When I check for plus or minus in here, if the question has a even number, okay, the power is an even number, you have to think about the positive and negative both integers. Okay, positive and negative integers. In this case both are possible. When you found positive 2 power of 6, it should be 64. Negative 2 to the power of 6, it should be also 64. So in this case r can be positive 2 or r can be negative 2. There are two possible values. Okay, there are two possible values in this case. Okay, mostly you will receive these kind of questions in your part 2. They will give you some kind of data like this and ask you to find the common ratio, possible values for common ratio. Okay, that is the thing. Yeah, T7, and we know the common ratio. We should find the first term of this number pattern. Geometric progression. T7 a into r to the power of 6. R to the power of 6. We know our T7 is 1 upon 128. We have to find our a. R 1 upon 2 to the power of 6. 1 upon 2 to the power of 6. Okay. Here I'll write 1 upon 128 a. Okay. 1 to the power of 6. For 1, if we put any power for 1, that should be 1. Okay. 2 to the power of 6. 2 into 2 into 2 into 2. Likewise, you have to multiply. It's 64. It's 64. Okay. To get our a, yeah, you have to take this as a numerator here. So 64 upon 128. 128, that is going to be our a value. How I found this? Yeah, this 64 in division, I have to take that as a multiplication. Okay, finally when you simplify, 64, 128 to 1. So a equals to 1 upon 2. A equals to 1 upon 2. This is the first term of this particular geometric progression. Okay, let's see. Here T6 means T6 a into, yeah, here our a is 160 and we have to find our r. Okay, and the sixth term T6 1215, you should find your r. Okay, in this case T6 a into r to the power of 5. Okay, T6 1215 a 160 r to the power of 5. Okay, we will simplify this. 1215 divided by 160. Okay, we can simplify this as much as we can. So when you simplify, you will receive your answer. When we simplify this by using number 5, it's 32. And here 3, 4, 2. Yeah, 243. R to the power of 5. 243 upon 32. 32. Here r to the power of 5. 243, 3 to the power of 5. 32, 2 to the power of 5. Okay, 2 to the power of 5. So r is equals to 3 upon 2. R is equals to 3 upon 2. Okay, we can write it as 3 upon 2 whole the power of 5. Whole the power of 5. Okay, when we cut off these powers, r equals to 3 upon 2. This is the common ratio for this question. This is the common ratio for this question.